Okay, so if you guys take a look at this problem, it's basically the same thing that we've been doing, right? We got a chemical equation. We have two starting numbers, so make sure you guys write the starting numbers down too. Our starting number is 10 grams of Al2SO3, and the other starting number is 10 grams of NaOH. Make sure you guys write that down, just so you have that. No, don't write the question down. Don't copy down the stoichiometry. Just copy down the balance equation, and that we got 10 grams of this chemical and 10 grams of this chemical. Okay. Yeah, I said don't copy this part down. Just the balance equation. Okay, so you don't need to do this whole stoic thing. I already did the stoic for you. This is just up here as a reference. But let's just say that if we start with 10 grams of this and 10 grams of that, we know that we're supposed to do two stoic problems, right? And we are looking for Na2SO3. And so that's what I did right here for you. I did the calculations, and I have two different numbers for Na2SO3. Now, we already know how to pick the correct answer. Which number should we pick? The smaller one, yeah. So the smaller number is 12.85. And so this is the correct answer for part A. And the bigger one, we can just ignore. So what that means is if we combine or react 10 grams of this guy and 10 grams of this guy, we are going to produce 12.85 grams of this guy right here, okay? So far, so good? Okay, this should be a review from what we've been doing. And so let's answer part B now. So part B, it's asking us to identify the limiting reagent and the excess. So the limiting reagent is the chemical that makes the smaller number. So the smaller number is 12.85. So the limiting reagent is this right here. So make sure you guys copy this part down because we're going to actually start the real problem now. Al2SO3. And then our excess is going to be the chemical that makes the bigger number. And so the chemical that makes the bigger number is NaOH. You can format it however you want, as long as you get the correct info on it. No, we're not filling the whole page. Okay. All right, so again, this is pretty much just review what we've been doing. Any questions though before we move on? We're gonna do an actual, or I'm gonna have you guys try a stoic problem on your own. Okay. So let's do part C. Now in part C, it's asking you to find how many grams of ALOH3 you can make. So if you guys notice, we have numbers for every chemical here, right? We have 10 grams of this, 10 grams of this. We know that we made 12.85 grams of this guy. And so what we're trying to do now is we're trying to find how many grams of this chemical we're gonna make. Now, the first time we did our stoic, we needed to do it twice because what we needed to do was find the limiting reagent. But now that you know what runs out first, you can just use the limiting reagent to solve for this compound. So Al2SO3, it's 10 grams. So we're gonna start off with 10 grams of Al2SO3. And then what we're going to do is just regular stoichiometry. We're going to set up 3 fractions. We're going to do our whole gamma thing. And at the very end, what you're looking for is AlOH3. Okay, thanks. Okay, so I'm going to give you guys about 2 minutes to try solving this problem. Now, what I do want to let you guys know is you do not need to find the molar mass for this right here because I already did that for you. The molar mass of Al2SO3 is this number right here. So I know that molar mass is kind of tricky, and so I already did it for you. It's going to be 294.15 grams per 1 mole. Okay, so thank you. Take about 2 minutes to finish up the rest of that fraction. And then after that, we will go on to the last part of the problem, okay? So take about 2 minutes to solve out part C. Should be doing stoic. You're gonna need a periodic table for the molar mass. Okay, so I gave you the molar mass of Al2SO3, so we can just copy that down on the first fraction. Next, we're going to get rid of moles of Al2SO33. That's a long chemical. And then we're going to try to find moles of AlOH3. Okay, so we just need to go to the balanced equation now. Al2SO33 has a 1 in front of it, so we're just going to put 1 on the bottom. And then AlOH3 has a 2, so we're going to put a 2 in the front. Okay, so that's what your second fraction should look like. And then for the last fraction, you're going to put moles of AlOH3 on the bottom, and then you're going to need to find the molar mass. So this one, you got to use the periodic table. If you look up Al on the periodic table, you're going to get, let's take a look at it. Al is 26.98, which is about 27, so we can do 27. Oxygen is 16, and if there's 3 of them, that's plus 48. And then 3 hydrogens is plus 3, and it's going to be 78. So the molar mass of this compound is going to be 78.
Why is oxygen the only solid number out of all the?
They're all approximations. Some of them do have solid ones, but we just make oxygen the 16. Yeah. That's close enough. That's fine. Yeah. It's because you didn't round the Al, but that's okay too. Okay, so let's do the stoichiometry now. Okay, so we're just going to plug it into the calculator. So super simple. Multiply the tops, divide the bottom. So 10 divided by 294.15 times 2 times 78. Your final answer will be 5.3. Yes, 5.3 is good enough. Okay. All right, so what that means is we have 5.3 grams of AlOH3. Okay, I'm just kind of putting the answer up here. Okay, make sense? Hopefully that's not too bad. That part is the review. It's the stuff that we've been doing. But what I did here is just on the top, organize the numbers so that we know how much of each chemical we have. Okay. Okay, so now we're gonna move on to the picture part, which is the new stuff. Does anybody have any questions? You guys ready for the picture? It's super easy. We're not drawing anything too crazy. You guys know how bad my drawings are. And so what I want you guys to do is I'm going to erase this real quick. But what we're going to do is we're going to take a look at the balanced equations. Just look at the thing that I have on the very top of the screen, the balanced equation and the numbers that we got for all of the chemicals. Okay. Okay, so when we draw our picture, we're not making an elaborate picture or anything like that. All we're going to do is we're going to start off by drawing 2 boxes. So make them a good size because we are going to be writing inside of it, but you don't need to fill up like half your page or anything. Okay, so what we're going to do is we're going to draw 2 boxes and we're going to have an arrow in between them. Okay, so take a second to do that. And this is basically going to be our picture. We're just going to be putting stuff into the boxes. Not really a picture, more of a diagram. Okay, so the left side, the left box, what we're going to do is inside of the left box, we're just going to put the chemicals that you start with. Okay, so the chemicals we start with. Okay, so if you guys take a look at the equation, obviously the chemicals we start with are the stuff on the left side, right? And so I'm just going to write down that I start with this guy right here, Al2SO3, and I also start with NaOH. Okay, so super simple. Okay, next we just, what's up? Oh no, we need to write down the numbers. So how many grams of this guy do we have? 10. So we just write 10 grams of this guy, and then the other one 10 grams. So we're done with the left side of the picture. That's it. Okay, now the right side of the picture is basically what we have at the end. So chemicals at the end. Okay. So if we run a chemical reaction, obviously the stuff that we make is what we have at the end, right? So we have 2 chemicals that we make in this reaction. So we have the products. So we have Na2 SO3, and we have AlOH3. So we're just going to copy those down. Okay, so picture is pretty simple, nothing too crazy. And then we just write down how much of each of those chemicals we have. How many chemicals do we have for the first, or how much of the first chemical do we have? Yeah, we did the math and we said that we have 12.85 grams. Okay, and so this is why I've been telling you guys, make sure you write your units of measurement, because if you just put the numbers, at the very end, it's gonna start getting confusing. You're not gonna know which chemical the number goes with, and so you're gonna have a hard time keeping track of it. So if you haven't been doing it, today would be a good day to start doing that. Okay. All right, and how much AlOH3 did we make? Yeah, 5.3 grams. So we calculated that too. Okay. All right, so if we think about it, do we have any other chemicals that we should put at the end? We do. And so let's think about it. We've been talking about limiting reagents, right? Limiting reagents are the chemicals that run out first, right? Which one of these chemicals ran out first? Wait, which one ran out first? Okay, so let's go back to the calc. So which chemical ran out first? Yeah, this chemical ran out first, right? The Al2SO3. So what that means is when we ran our chemical equation, what happened is we ran out of this guy, right? This guy disappeared completely. But did we use all of this? No, we didn't use all of the NaOH, which means at the very end, we still have some of the NaOH left over, okay? So what that means is on the left side, these are the chemicals we want to put on the left side. We want to put the reactants. One sec. Okay, and on the right side, we're going to write the products, this chemicals on the right side, and whatever chemical was the excess. That's what we put on the right side. So these are the chemicals you put on the left side, the reactants, and then on the right side, you're gonna put the products and the excess. Yeah, what's up?
Will we ever use milligrams?
Usually no. Okay. Yes. All right, and so what that means is we still need to find out how many grams of NaOH we have. Okay, so we need to do one final calculation. Okay, luckily it's pretty easy. If you take a look on the left side, what's the total mass of everything on the left side? 20, right? 10 plus 10, so the total mass is going to be 20. Good. Okay. And so what that means is the right side also needs to have a total mass of 20, okay? Because you can't magically get rid of stuff. Okay, molecules don't just disappear. Okay, we just turn it into different types. Okay, so if we have a total mass of 20 on the left, we need to have a total mass of 20 on the right. And so we know that we have 12.85 grams of this guy. We have 5.3 grams of this guy. And so if we want to find out the mass of NaOH, all we need to do is take the total mass, 20, right here, and we're just going to subtract the chemicals we already know the answers for. So we're going to subtract 12.85, we're going to subtract 5.3, and that's going to give us the mass of NaOH we have left over. So just need to go to our calculator, and then we're going to do 20 minus 12.85 minus 5.3, and so our final answer is going to be 1.85. And so that is how you find out how much excess you have left over. Okay. So this is going to be leftover chemical. And that's it. That's what you need to include for your drawing. Just two boxes, left side, right side. And all you need to do is write down how much of each chemical you have left over in there. Okay, so you do all the hard part during the stoichiometry. All you need to do for the drawing is figure out how much excess you have left over and just organize everything in the correct spots. Okay. And congratulations, guys. That is Unit 5. We have a lab on this 2 weeks from now, and then we have the exam as well. Okay, I'm actually debating whether we should combine do a lab exam instead, but we'll see. See, but now that you're like, no, I'm just like, yes, we have to do this now. You know what? I'll think about it, guys. Alrighty, guys. I'll give you the rest of the class period to work on the assignment. Let me know if you want to check your answers or if you have any questions.